Engineering a World with Strings Attached, the place of the Kipu in building the Inca Empire. Eminent scholar, friend of our museum, Dr. Gary Urton, will now share the fruits of his research and insights in a presentation on the Kipu, the knotted mnemonic device of the Inca people. Gary Urton is a Dumbarton Oaks professor of Pre-Columbian studies and chairman of the Department of Anthropology at Harvard University. His research focuses on a variety of topics in pre-Columbian and early colonial Andean intellectual history, drawing on materials and methods in archaeology, ethnohistory, and ethnology. He is the author of many articles and editor of several volumes on Andean Quechua cultures and Inca civilization. His books include The History of a Myth, The Social Life of Numbers, Inca Myths, and Signs of the Inca Kipu. A MacArthur Fellow as well. He is the founder, director of the Harvard Kipu Database Project. Welcome, Gary Urton.
Thanks very much, Jose, for that kind introduction. And to begin, I just wanted to thank the Smithsonian Institution for inviting me here to take part in this very important set of events related to the planning of an exhibit on Inca engineering. I do just want to say to begin with that when I was doing my doctoral dissertation fieldwork that Ed Frankelmont, who was just honored by John Oxendorf, was doing his field work in the village across the way, and I spent much time with him and learned a tremendous amount from him. I also want to say that I learned about John Oxendorf's work about 10 years ago, and in my book, it's the most exciting work that's been done in the Andes in a very long time. If I can get the get my image up here, can someone? Yes. Is that me? Yeah, it's probably me. So in Secretary, right. In Secretary Clough's introductory comments this morning, he was talking about how the Inca had accomplished all of these fantastic engineering constructions and accomplishments without a writing system, and that is the case. And they did, on the other hand, have a record-keeping system, and I've been involved in the study of the record-keeping system for the past 20 to 25 years or so. I'm usually invited to speak on the record-keeping system when we talk about it and wring our hands about whether it was a system of writing or not. And I just want to say I'm very pleased to come to a conference to talk about the Kipu in terms of straightforward record keeping and ask the question about the value of a record keeping system in relationship to maintaining calculations, maintaining data that related to this extraordinary world of engineering accomplishments that the Inca were so noted for and that we're seeing today. Just to give you a little bit of the context of the keeping of records in the Inca Empire, not to say that you don't have it already, because from Ken Wright's presentation and from the presentation on Cusco and John's on the Inca, we can understand that there were an enormous number of engineering projects that were put in place by the Incas and that were maintained by the Incas over time. And if one thinks about it for a short time, you realize that this all involved a tremendous amount of calculation, of measurement, of the recording of data, of the calculating of ratios and proportions, and calculating things from model to and scaling them up to the actual place they would be put in place in the environment. And so some kind of record-keeping system would have been essential, and I'll get to that after, once again, a little bit more laying the foundation or establishing the broader context for its use. So we are talking about the Inca Empire, which was the largest empire in the pre-Columbian New World, stretching from the present-day border between Ecuador and Colombia and running some 5,000 kilometers along the spine of the Andes to a little bit south of Santiago de Chile. The Inca Empire was divided into 4 quarters. The name of the empire was Tawantinsuyu, the 4 parts divided together. To emphasize a point made by some of the other speakers, the Inca Empire was situated within one of the most complex environments in the world, spanning the region from the Pacific coastal desert to the west to the high Andes, rising to some 20 to 22,000 feet above sea level, and then dropping precipitously down to the headwaters of the Amazon in the zone called the Ceja de Selva that gave off to the upper Amazon basin. So this was a tremendously vertical environment, and that verticality and that change of environments was compressed in some places within only some 200 miles from the Pacific coast to the headwaters of the Amazon in various parts of Peru and Ecuador. So it was a very complex setting. One observation about this was made by my colleague at MIT and John's colleague at MIT, Heather Lechtman, when she talked about the nature of Andean technologies and noted that abandoning the Western overemphasis on sophisticated hardware, because you simply don't find that when you look at the engineering in the Andes, Andean systems of technology were heavily weighted on the side of management in 2 senses: management of the physical environment, an environment that was and is the dramatically dominant feature of the Andean zone of South America, and management of the social units of production, whether at the community or the state level. And we just saw an example of that with the building and the maintenance of the Huinchiri Quechua, the bridge that John just told us about. But I want to talk about that issue of management, because I think this is where the Kipu came to play, that it was probably the principal instrument of management in the Inca Empire. So as I mentioned, the empire was divided into 4 quarters. It was known as Tawantinsuyu, the 4 parts intimately bound together. The whole was bound together in terms of the movement of personnel and materiel by the Capacñan, or the Inca road system. There were 2 main trunk lines, one that ran along the coast and the one ran through the Central Highlands, with roads that connected them at certain strategic places, and some of those were the spots of the bridges that John just told us about. So that road system passed through the high Andes and down into the tropical forest, some images of which you see on the right, and in the lower left then you see a small stretch of the Inca road along the coastal desert, and in some places these had 2 or 3 parallel tracks of road. So the system was extraordinarily complex in terms of its construction, and certainly in terms of its use and the sort of regulation of traffic moving along the road. There were a number of installations along the road. These were important for us to think about in terms of engineering those buildings and of just putting all of the infrastructure in place for travel along the road. So we have large installations like the one on the upper right, which is a site in northern Chile that has a very large compound building called a Callanca, and then you have just tens and probably actually hundreds of small way stations called tambus, like those shown on the bottom right, where travelers could stop and could refresh themselves and sleep for the night, change their llama herds, whatever you do with that, with llama caravans. And so that infrastructure all existed as a part of it. And then, of course, we just heard from John, the master of telling us about and bringing to us the message of the Inca bridges themselves. They actually made the whole thing possible by allowing travelers to cross those great chasms through the Andes. And what's interesting to me here about the business of rebuilding the bridge now is that sort of work requires cooperation, and it requires coordination, and it requires management. And that's the sort of thing that we're aware that exists to the present day, but that existed in the Inca times as well. And I want to talk more specifically about that in a moment. So we do have then a whole set of buildings and various kinds of structures with their particular architectural features that were the central facilities of the Inca Empire that were spread throughout the the Andes, and these buildings, which are not terribly complex themselves but are quite sturdy, of course, these are a part of the products of engineering that we need to be aware of and take account of. And that includes then also the extraordinary work in stone cutting, which the Inca Masons were masters at, that we heard about this morning from the organization and the building of Cusco, and that was so important. So again here, just to emphasize the fact that in some of these large buildings, some with internal spaces that span some 100 to 200 meters or so, those buildings had to be built. The structures, the walls had to be built, and were built with great regularity in terms of the layout of the different features of the sites, like the internal niches. And so this required measurement and the calculation of various features of the constructions themselves. And I think that those calculations were recorded on the Kipu, and we'll talk about that in a moment. The stoneworking, of course, was not terribly complex in terms of the tools. So again, they were working stones primarily with stone on stone, abrading stone, working with water, thawing and freezing, wooden wedges that were driven into fissures in the live stone, and then once the stones were cut and shaped, then they were moved into place by manpower, by human power. That was organized to move the stones across the landscape, and that's a very important part of this system of management, managing the labor of doing all this. I happen to have the fantastic opportunity to see that kind of thing at work under different political, economic circumstances when I was working when I was directing an archaeological field school at Tiwanaku, just south of Lake Titicaca in Bolivia in 2006, when the state was trying to reassemble the stonework that was the stonework on the summit of the main pyramid at the site of Tiwanaku. So it has since been ravaged and a lot of the stones broken and thrown down from the top. And they organized local labor to get those stones back in place. And it was done then by groups of workmen who came together and working with wooden staffs. Then they pried up the broken stones from the lower part of the pyramid itself, raised them up, and moved them onto sledges, moved the sledges using nylon ropes, the modern day version of the grass ropes, of course. A grass rope would serve equally fine here. Moving them onto the sledges, pulling them up from the lower level, and getting them up to the top of the pyramid, and then of dragging it across the summit, and then unloading it from the sledge, tipping it over, and once they had it in place where they wanted it, slipping it off the sledge and getting it down. And then, of course, once you accomplish a task like that, then you have to celebrate things, so they pull out the coca and the trago, and everybody has a drink and has another chew of coca, and to get regenerated for pulling the next one together. But that's the kind of activity that has to be organized. People would prefer to be out in their fields doing their own business, but someone organizes this kind of work, and this was a sort of organization that went into not only building bridges but building roads and all of the infrastructure of the building. In the Inca Empire, this was done through a decimal system of organization. So the Inca levied tribute in the form of work time. So every subject of the empire was required to work a certain number of days every month for the state. And so those work groups formed at the local level in work groups of 10 here. So you would have chunka, 10, a group of 10 workers who could be put to a small task. 5 groups of 10 workers could be put together into a larger group, work group of 50 2 groups of 50 could form a larger work group of 100, and so on up to work groups of 500, 1,000, 5,000, 10,000, up to 40,000 or so. So they had the organizational structure for bringing together work groups of various sizes and set them to work doing the work of the empire. This was explicitly a context for the keeping of records, and we have statements in the chronicles about how the Incas kept track of time, and they kept debits and credits. If you worked more than you were required to work, then you got credit for it, and so there was a whole sort of accounting of time that was important in record keeping. Also, for bringing those workers together, you had to have an efficient census system to know the count of the population in this village and that village and organizing them into groups. And we know from the chronicles that they did keep a census. They did yearly censuses and revised the whole thing every 3 to 5 years. It's not exactly clear. All that information was recorded on quipus, these knotted string devices that we're going to be talking about. And all of those data went from the local level up to the level of an administrative center, and ultimately they would be sent to Cuzco. The data could be shuttled around the empire as well, because the Inca had a system of messengers called chasquis who traveled with the quipus with their information, taking them from one place to another. And here we have a late 16th, early 17th century drawing in which a runner is running with one of these knotted strings, but he has a little sign on it that says carta, so to inform the reader that he's carrying a letter. Right? But what he's actually carrying is the knotted string record. These knotted string records would be produced locally. From there, they would be sent to a central place. Ultimately, they would all go to Cuzco, and then in the end, they would be redacted or brought together, synthesized, aggregated into larger quipus, these very large knotted string devices. So we want to talk about the quipu, and you're looking here at a sort of potpourri of several quipus from what is the largest collection of quipus in the world. That's in the Museum for Volkerkunde, or the Ethnological Museum in Berlin. They have about 350 quipus there. There are some 850 quipus that exist that are extant from the end of the Spanish era. These devices are made of spun and plied either cotton or camelid fibers, so llama or alpaca fiber, spun and plied, and often the alpaca fibers are dyed in brightly colored forms. So I think the quipu was important in engineering for a variety of ways, and I'll just talk about a couple of them here. One is as a paradigm, and I think the Inca road system with its main route and with notable places, the named places, the places that would have all been understood as having a particular identity, and probably, given what we know about the Incas, also a hierarchical relationship, one to the other, I think was thought of, or could be thought of, as similar to the Kipu cords, which are these strands of spun and plied fibers with that are knotted. And so I think there was a relationship here between the sort of general structure of the Kipu and the structure of the Inca road itself. The city of Cuzco itself, as we heard this morning, it was actually divided into 2 halves. There was a moiety system, there was Upper Cuzco and Lower Cuzco. The whole system itself, or the whole valley itself, was organized for ritual and political purposes by a system called the Seki system, which was a series of 41 imaginary lines that went out from the center of the city and that organized sacred places called wakas, some 350 of them, along those 41 lines, and that was the sort of framework for ceremonial life and for the ritual calendar in the city of Cuzco. And so that you had a system, something on this order, and those Seki lines, those lines of orientation with their sacred places located along them, I think would have been understood as similar to the quipus with their strings and their knots. So let's look at the Kipu as a recording device. So we know now we need to record numbers. We need to record them for the administrative system and for a variety of other purposes. Kipus have basically the form you see in this example, which is from northern Peru, from Chachapoyas, has a main cord. We call the primary cord that runs horizontally, from which are suspended all these other strings, which can be of a variable number, from between 2 to, we have some quipus with 1,500 cords. So these are quite large things that take 2 people standing side by side to actually suspend the quipu from their hands. They have cords that are suspended from them that we call pendant strings. Lots of pendant strings carry what we call subsidiary strings or secondary strings, and you can have subsidiaries of subsidiaries of subsidiaries, and we have examples of 6 hierarchical levels of subsidiaries affixed to a single quipu. So this was a hierarchical structure much like that hierarchical decimal system of organization that we saw. We have other kinds of structures then also, like top strings that bind together the attachments of groups of pendant strings. I'll talk about this in a moment. And another structure we call the loop pendant. I won't get into that so much now. But here they're recording numerical values. They're recording all the quantitative data important for engineering and for other purposes like the census. When we talk about numbers, we have to note that unlike their contemporaries, the Maya and the Aztec, who used a vigesimal system, a base 20 system. The Incas used a base 10 system like us. I've always thank God I worked in the culture that did the decimal system rather than the vigesimal system, much easier to work with. And and for administrative purposes, they spoke the Quechua language, and Quechua was a base 10 decimal system. The knots themselves are organized in tiers, which are the tiers of a place value decimal system of recording decimal values in those tiers, so that the decimal system works as our system works, that we can write a number in a horizontal string. We know that the 1s are to the right, the 10s are to the left of those, the 100s are to the left. The Inca system worked the same way, but it's rotated 90 degrees clockwise, so the 1s are at the bottom, then the 10s, then the 100s, then the 1000s. And they had several different kinds of knots they tied to record values in those different places. The majority of the knots were used to indicate one or another of the values between 1 to 9, down in the units place down here. All the 10s, 100s, 1000s, and 10,000s were signified by an overhand knot, just a very simple, I call granny knot, overhand knot, right? And tied in a place value. So basically that's all the information you need, and now you can go out and study a quipu and you know how to read the numbers on a quipu. So that they would tie different groupings of those knots then in different tiered configurations to sign numbers. And it's important here to note that they knew the value of 0 and they used the value of 0 in their calculations. In terms of the calculations, the quipu then was not like an abacus. An abacus, you move beads on rods. You can shift them up and down. The quipu, you tie fixed knots. So the calculations have to already be done. And so the calculations, we think, where we have some chroniclers' accounts where they talk about people dropping down on the ground and shuffling stones around or kernels of corn around. And in some cases then we learn about counter stones with multiple slots where we think they were working with those stones, working beads around them to do the calculations. Excuse me. And one of our colonial chronicles shows a man holding a quipu with a board here with different stones and slots, and there have been about 2 tons of ink spilled on trying to analyze how that counter stone on this particular drawing would have worked. We have some quipus that give us evidence that in fact they were recording numerical values, and these contain those top chords that I talked about. So this is a drawing of a quipu in the museum, in the Natural History Museum in New York. And in this quipu you have groups of 4 chords that are bound together by a top chord, and you have then the number recorded on the top chord that is the sum of the values on the group of chords that the top chord binds together. So 612 overall recorded here, 612 recorded there. So it's a system of sort of checking the calculations, and we have several other examples of that. So, but we know how to read numbers on Kipus, but our big problem, and it's the great challenge of Kipu studies, is so if you can say that string records the number 602, then 602 what? And there's is our stumbling block, is that how were they recording identities? And we think one of the main ways they were doing it was through color. So there's a fair amount of dyeing of camelid fibers, and the Inca grew cotton in some 4 or 5 different colors, and so the cotton quipus are spun in different colored groups of chords of different color. So color was very important, but I don't have time to stop and talk about color now, or we'll be here till tomorrow morning. So, but that was very important, and we have to deal with that issue. There was a cadre of Kipu keepers, people who were responsible for this. It was a hierarchy of them. The head Kipu keepers were in the capital in Cusco, and then lower, mid and lower level ones were distributed out into the countryside. Census keeping was a very important part of the task they were charged with, and I want to just show you the analysis of one Kipu where it seems to me we have a pretty clear example that this is probably a census Kipu, although again we can't read it. We can't actually read the names of anything, but what we can see is the organization of numerical values. So the one I'm going to tell you about is one of 6 Kipus that are tied together. We have several cases of this. This is from the Museum für Volkskunde in Munich, and it's that Kipu I'm going to tell you about. And we'll draw a schematic diagram of the chords of that Kipu, and here they are. There's a total of 74 strings, and they're organized in these groups for the reason that I'm going to explain to you. In terms of the way this table is laid out, there are chord numbers. So that at the top, that's the first chord. So that's just arbitrarily beginning from one side of the Kipu. We don't really know if we're looking at the right side of the Kipu when we're here, if we should turn the Kipu over. So right and left is a big problem in the study of the Kipu. But here's the first string, the second string, it has a subsidiary, the third string with a subsidiary, fourth string subsidiary, fifth, sixth, seventh, eighth, ninth, 10th, 11th, ninth, 15, 16, 17, 18, 25, 26, 27. So I've grouped these in a way that's going to look quite odd to you, but I'm going to explain it to you in a moment. The chords are basically of 2 colors. They're AB, light brown, or MB, medium brown. So almost all of the chords are of one or the other of those 2, AB or MB. Then to go on, then we're going to read the knot values. You know how to read the knot values, and those are recorded in those blue-white boxes in those columns. And then we're going to sum those, and those are going to be recorded at the far right on the different columns. So we know now the first chord we see here, it contains the value 102. Chords 2 through 4 with their subsidiaries, they also sum 102. Divided into the chords themselves and their subsidiaries. And we see here the chords total 54, the subsidiaries total 48. So that's interesting. You say, well, you know, 1 chord totals the same as 3 chords and their subsidiaries. But then what's interesting is we'll step back and we'll take this group of figures right here as a sort of guide, and then we'll look at this first group of strings that we set apart here, 5 through 9, 15 through 19, 25 through 29. They sum the same as the first chord itself. Its subsidiary carries 14, and it's the same as the strings 10 through 14, 20 through 24, 30 through 34 there. The next string has 13, and that's this value. The next one has 10, that's that value. The next one has 12. I think there's a bad job of adding here. The guy meant to write down or not down 12, and he knotted down 14. Then there's 24 here, down to there, and we actually have 104 registered here, but I think it's referencing this 102, which is the base number that they're interested in. So I think what we're looking at here is a Kipu of one of these units of 100. So 100 was this level in the decimal organization. Whoops, let me get back here. Is this unit, you have groups of 10, then groups of 50, then groups of 100. 100 was a group very important. It was actually a name, a size group that was often related to the main social group in the Andes, which some of you will know was the Ayllu. The Ayllu was often alternately called a Pachaca, a group of 100. So we have the group of 100 here. And I think that may be what's being accounted for in this Kipu. We have 102, we have 100 down here. And as we recall, those groups of 100 are composed of two groups of 50. So up here, again, there's a group of 54 and a group of 48 equaling the 102. So I think this is the way, that kind of information that had to be pulled together, synthesized, and checked and rechecked. So we have 3 different recordings of the value 102. Yeah, that's how many people are in this accounting group, right? What did I do? Oh, okay. Yeah, so I think that this was a cord keeper. And then we have other cases like that. I'm just going to give you a couple of examples just to sort of show you how they were handling numbers, organizing numbers to arrive at the same value, but using different groups of numbers, different groupings of numbers to arrive at the same value. Something that one might want to do if you're establishing or calculating ratios or proportions, etc. So here's a Kipu that has groups of Kipus divided into 2. The first group totals 152. The second group totals 152. And you can see that the sets of numbers that they use to arrive at those two values, those two equal values, are different. So they're getting at a value of 152, and they're trying to see how you get there in different ways. Here, a Kipu divided into 2 big groups, 247 for this group, 247 for that group. They may also be doing some kinds of checks and balances business here as well. And this is a complicated one where you have on the first string 30, you have 32, the second string 26, and then this, or I'm sorry, 37 and 26, totaling 63, and then that's on those 2 strings, and then down here there's an organization of strings into 37 and 26 like we saw up here. So again, there's a lot of ways you can skin this particular cat, I guess, and get to these values, adding sums and checking sums in various complicated ways. And then the last one I'll show you is this Kipu, a beautiful Kipu in the museum in Paris that has, if we blow up the figures here, we can see, so here's the color key, and the first 8 strings, strings 1 through 8, total 43,372. The remainder of the strings are in groups of 9, from the 9th chord up to the 32nd chord in these various groups, and they total the same as we have up there. So again, it's showing, we don't see the calculations, but the calculations must have been done in some way, and we can see then how they were able to record these numbers that were the result of fairly complex numerical calculations that, and I think all of this was sort of at the core of the record keeping and of the calculations that were central to this building of the Inca Empire, which was an empire based, again, as Heather Leckman points out to us, on management, managing the environment and managing social units. And the management of those social units was in terms of the census and the administrative system. And so I think the Kipu, we can understand the Kipu as a critical tool in the practice of engineering in the Andes. So thank you very much.